So we'll start with the projectile motion. So before going on to the main projectile motion, the terms of projectile motion, the equations of projectile motion, we will discuss some basics about the projectile motion. Okay. So what comes in here is firstly the position. So the position can be of a point object that can be in a space. So for the better definition of a position, we can define a position of any object in space which is that point in space at that instance of time. Next we have the displacement. For the displacement is nothing, as we know, it is the change in the position of the particle which is traveling in a particular direction. Okay, suppose if particle goes from here to here, then the distance, basically the distance traveled by the object, we called this as the displacement. Okay, that is the change in the position. Next we have the path length. Okay, for the path length, it is the actual distance traveled by the object during its motion. Okay, starting from the initial point to the final point, the actual distance traveled by the object is called as its path length. Next we have the average velocity. Okay, velocity is nothing but change in the speed, velocity is nothing but change in the displacement with respect to average velocity is nothing but the change in the displacement upon the time taken for the displacement to change. Okay, so that is change in the displacement is given by x, so that change is delta x upon the time taken for that change is time delta t, that is the time from initial condition final to the time for initial. Okay, so we have to minus this and we'll get the actual velocity of that particle. Average speed will be nothing but the path length upon the time interval, that is the actual path traveled by the object upon the time taken by the object to travel that much of the path. Next we have acceleration. Acceleration is nothing but the change in this velocity with respect to the time. Okay, change in velocity, that is the change that the particle has taken, that is the change in the velocity of that particle with the change in the time. So we have to divide the change in velocity upon the time required for that much of change. Next we have the kinematical equations. This kinematical equations gives us the basic displacement, time, initial, final velocities of the particle performing any kind of motion. So we have three equations: v equals to u plus at, and second equation is s equals to ut plus half at square, and then third is v square is equals to u square plus 2as. Now here v is the final velocity, u will be the initial velocity, t will be your time, a will be your acceleration, s will be your displacement. Rest all of them are same. V final velocity, u initial velocity, a will be your acceleration, t will be your time, and s will be your displacement. Moving on to the projectile motion. Firstly, what is a projectile? Projectile is nothing but it is when an object is thrown in air with an initial velocity, it makes an angle with the horizontal, and it moves unfreely under the action of gravity. Okay, so the path that it traces, it is called as the projectile. So now we have something called as the velocity of the projectile. That is that the velocity with which the body is projected is called as the velocity of projectile. That is the velocity by which the body is thrown or it is projected is called as the velocity of this projectile. Angle of projectile, it is the angle which the body makes with respect to the horizontal is called as the angle of projectile. It is always making some angle with respect to the horizontal, that is called as the angle of projectile. Now we have the path followed by the projectile in space is called as a trajectory. This path followed by the projectile in space is called as its trajectory. Now we need to find, in order to know the entire terms, like how much angle we need to find, what is the velocity we need to find, what is the distance traveled by the object we need to find, or what is the height of the object, maximum height of the object we need to find, or what is the time taken by the object to go from the initial to the final position we need to find. So for that we need some equations. Okay, so basically we will start with the basic equation. We will find an equation for this trajectory alone. For that equation we need to resolve this u. U is your initial velocity. Here the initial velocity is u, final velocity will be v. Okay, so the angle theta, here the initial velocity u can be resolved into two parts. One along the y-axis and one along the x-axis. So for the x-axis you use cos theta, and for the y-axis you use sin theta. So as you can see, there's a box out here. If I draw it like this, what I get is I get a square. Okay, and I get this angle. Out here I get theta, and again out here I get second theta. Okay, this line is center line is my u. Okay, this along the x-axis will be my ux, velocity along the x-axis. This along the y-axis will be my uy. Okay, so if I consider this theta, I'll take it the cos of this theta. So cos of this theta gives me, cos theta is adjacent upon hypotenuse, that is ux upon u. So ux becomes u cos theta. I have taken the u on that side. Next, again sine theta, I am taking the sine theta of the y-axis. So sine theta out here becomes opposite upon hypotenuse. Opposite is uy upon u. So uy upon u. So ui becomes u sine theta. I have got two values for the velocity along the x-axis and velocity along the y-axis. Now, moving further, we'll find the horizontal distance traveled by the particle. That is, we need to first find the time. So for that time, we need to find the horizontal distance traveled. So how much distance is traveled by this? This distance is along the x-axis, so will be x into horizontal distance travel into time. So our distance travel is nothing but velocity into time. As velocity is equals to distance upon time, distance is equals to velocity into time. So horizontal velocity here is u along the x-axis. Okay, so ux is the value of ux is u cos theta. So I have substituted u cos theta over here into time t. So the time t, putting this u cos theta below this, below x, you get t equals to x u cos theta. Now, after getting the equation t equals to x upon u cos theta, we found the time. Now we have the kinematical equation for the displacement. S is equals to ut plus half at square. S is the displacement, u will be the initial velocity, half, and a will be our acceleration. Now this u is along the y-axis. Okay, this equation we have to take it along the y-axis. So for the y-axis, your displacement s will become equals to, displacement will be along the y-axis. Why the y-axis? Because we have to find the path equation for the path of the projectile. This entire path trace, we need to find an equation for that. Okay, so that is along the y-axis. It is reaching something height, it is reaching some height, it is going vertically upwards along the y-axis. So we take the displacement along the y-axis. When you take the displacement along the y-axis, your velocity will become, your velocity is also along the y-axis, that is uy. And then your acceleration, while moving upwards, there is an acceleration. This acceleration works opposition, this acceleration will work in opposition to the to something which is gravity. So that is gravity. So this your acceleration, whatever acceleration you will give, that will be against, working against the gravity. So this acceleration will be against the gravity g. So acceleration along the y-axis will be against the gravity g. So minus sign because it is opposing. Now the time t becomes same. So u becomes your uy. Uy value is uy equals to u sine theta. We have derived it earlier. Okay, so I substituted uy, u sine theta, half a becomes g minus g, so therefore plus becomes minus, and t square. So we have the values for t. We substitute the values t out here. T square becomes x square upon u square into cos square theta. Now I have taken the sine upon cos out here. This cos goes below the sine, and the entire term becomes tan theta. So that is tan of x minus g upon 2u square cos square. I have put in the x square. I have removed the x square outside. Okay, so we get two equations out here. First is this equation for the y, for the path of the projectile, and second is this equation. This with the substitution of the time, and this equation is without the substitution of the time factor. Okay, so we have both the equations which are important, and using these two equations we will be finding the range, the horizontal path, the horizontal height, the range, also the time taken for the projectile to complete the entire projection, that is projectile motion. That is, it is starting from the initial point when it comes to here, and when it goes from here to the downward descent path. Okay, now we will be finding out the time taken for the projectile to complete the entire to complete the entire trajectory. So that is called as the time of flight. So time of flight is subdivided into two parts. One is the TA and one is the TD. TA is the time of action, that is the time required to reach the projectile at its maximum. Okay, whenever the projectile is at its maximum level, that much what time is required to reach its at maximum. And TD is the time required to its that is the descent time, that is the time required for it to fall down. Okay, come down. And the total time t we will be finding first the time of action. So we have the kinematical equation v equals to u plus at, where v, now this is moving in the upward direction, so our velocity also goes along the y-axis. So v becomes equals to vy, your u becomes equals to uy, again your a becomes equals to ay, that is acceleration. Now vy, the v is your final velocity, this is your initial velocity. Final velocity here out is 0 because this is the starting point. Initial velocity uy value we know, that is u sine theta. Okay, again acceleration with respect to y, acceleration in the y-axis, that is the acceleration is against the gravity, so we get this to be minus g, and your time t becomes the time of action, that is equals to ta. So vy equals to uy plus ay ta. Substituting the values, vy equals to u sine theta, vy equals to 0, uy equals to u sine theta, ay is minus g, so plus becomes minus, and ta. Okay, we need to find the time of action, so we take the time of action here and we put on the terms. So substituting the transforming the values, shifting the values, we get u sine theta upon g. So this is your time of action, that is the time required for the projectile particle to move at its maximum. Next, we need to find the entire time for the projection, for the trajectory, that is the total time t. We use the first equation, y is equals to u sine theta t minus half gt square, the first equation for the projectile which we derived earlier. Okay, again here we need to find the total time t. Okay, for the total time t along the y-axis, y becomes equals to 0. Okay, now this total time t, again u sine theta, the small t becomes equals to capital T, half of gt, the small t again becomes equals to capital T. Now it is along the y-axis, so this is this total time t will be, for here the y is equals to 0. Now u sine theta t equals to half gt square, we have put the gt's half t square over there, so we have half t square. What we need to find is the total time, the capital time t, barabar. So t gets cancelled, we get half g into u sine theta. Putting one t out here, you get u sine theta upon 2 u sine theta upon g. So this is your equation for the total time. Now we have founded the time of ascent, we have founded the total time, and now we need to find the time of descent. So that will be equals to total time minus time of ascent. Time of td will be equals to total time t minus ta. So td will be equals to total time t minus ta. Total time t we found out, that is 2 u sine theta minus g upon g, minus ta we found out, that is u sine theta upon g. Subtracting both of them, we get td equals to u sine theta upon g, that is this factor and this factor, that is the time of ascent and time of descent, both are equal and they both depend on the angle and the initial velocity. That is, higher the velocity, the initial velocity depends on the time, and also it depends on the angle. Okay, in here we will be finding out the horizontal range of the projectile. Here we have the projectile, and here along the x-axis we are finding the horizontal range. Horizontal range is nothing but the distance traveled by the particle in the horizontal plane, that is from here to here, this much distance is called as its horizontal range, that is given by r. We again use the final equation which we got earlier, y equals to tan theta x minus half g u square cos square theta along into x square. Now this horizontal range is along the x-axis, so here y becomes equals to 0. We need to find the value for this, so y becomes equals to 0. Here your x, that is equals to capital R, so wherever x is, we get capital R minus half g u square cos square theta, all this remains same. I have taken tan theta equals to sine upon cos, and I've shifted it out there, and we got is, moving it there, we get sine upon cos equals to half g r square r upon u square cos square theta. Now cancelling this r's, okay, what the value of r becomes after moving this all the values from here, moving it to there, we get r becomes equals to 2 u square cos square theta sin theta upon g cos theta. Again we have two causes, one cos goes and here another cos goes. What we remain is 2 u square cos theta sin theta upon g. As cos theta into sin theta, we have the equation we know sin 2 theta is equals to cos theta sin theta into cos theta barabar. So we get sin 2 theta. Now for the range, this range to be maximum, we don't need this sin 2 theta, we only need u square upon g. What the value should be is r should be equals to u square upon g. So for this to be r equals to u square upon g, the sin 2 theta should be 1. So for sin 2 theta should be 1, theta has to be 45, because if we put 45 out here, it becomes twice, that is equals to 90, and sin of 90 gives you 1. So at an angle of 45 degree, the horizontal range is maximum for any projectile. If at a particular velocity, if the angle is 45 degree, the projectile will be maximum. Okay, now we'll be finding the maximum height of the projectile. The maximum height of the projectile is the maximum height up to which the projectile can reach, this height or this height. It depends on the angle theta, of course, and it depends on the velocity. Okay, so we take the equation, kinematical equation, v square equals to u square plus 2as for the vertical motion, for this motion, for to go upwards. Here your v will be equals to, final velocity will be equals to vy. Okay, your u initial velocity will be again equals to uy. Okay, your acceleration will be again equals to ay, which is minus g. Okay, and your displacement s will be h, that is how much displacement you take run from the initial to the final position, that becomes equals to h. Substituting all the values, vy, what is the final velocity? It is of course 0, so we get 0 equals to u is uy value is equals to u sin theta, so we get square of that is u square sin square theta minus 2, a is g into s, this minus sign because a is minus g, so it becomes minus 2g h. What we need to find is projectile h, so we keep h over here, and then we find the value for h. The h value comes as u square sin square theta upon 2g. This is your horizontal range. Okay, now we'll find some cases in which at certain angle thetas, what should be our horizontal range and what should be our maximum height and what should be our horizontal range. Okay, so this h and r we need to find, where h will be your maximum height and r will be your horizontal range. Okay, we'll be taking certain angle thetas for which your h and r values will see. Now, what if the theta is 45? Earlier we have discussed that if the theta is 45, the horizontal range will be maximum. So your horizontal range r, if your theta becomes 45, it is maximum. What if the theta is 45? What will be your maximum height? So that becomes u square sin square 2 theta upon 2g. We substitute theta equals to 45. Sine of 45 becomes root 2, and root 2, the square of that becomes 1 upon 2, and that 1 upon 2 goes down, that becomes 4g. So your h max will be equals to u square upon 4g. Okay, so that is the first case. In the second case, we have theta equals to 90 degree. What if the projectile is along this direction? Okay, will there be any horizontal range? No, it should be 0. So let's see. H will be equals to u square sin 2 theta 2g, and your horizontal range, your vertical range will be your displacement, maximum height will be maximum. So u square sin 90 square, sin 90 becomes 1, so you get h equals to u square upon 2g. Now for the horizontal range, u square equals to sin 2 theta. Sin 2 theta becomes equals to 0. If we take theta equals to 90 degree, sin becomes 180 and sin 180 equals to 0, so that becomes entire r becomes equals to 0. So there will be no horizontal range for this particular format, there will be only vertical range. Okay.